Assalamualaikum and good morning. My name is Nurul Zaira. Today, my group and me want to present about force and factor of safety analysis from actual structures. A bridge consists of three components. The first are the superstructures, substructures, and foundation. It also includes beams, girders, trusses, arches that can directly support the load and transfer it downwards. The substructures includes pier, abutment, and bearing that support the superstructures. The bridge foundation can anchor the interior bridge to the ground and provide stability. Purpose of the bridge. This is a purpose of building the bridge so that it can be maintained in the detail. Infrastructure components include beams, girders, columns, and cables. It also provides access for workers to perform routine maintenance tasks. It allows for the execution of repair works, including welding and others. Okay, the bridge use ASTM A992 steel, which is a high strength low alloy structure steel with alloy used in construction. It can withstand impact load, which is crucial for withstanding dynamic force during maintenance operation. Okay, the last is safety. A bridge has high safety and stability even in heavy rain and strong winds. It also makes it easier for workers to maintain. This is because corrosion resistant material are used and minimize the risk of the structure failure. Okay, next I will give my partner.
Literature review. Material selection. When designing bridges, material selection is vital to ensure the bridge's safety and long-term functionality. According to CED Engineering Group 2021, steel ASTM A992 is widely used in modern bridge construction due to its excellent balance in strength, ductility, and resistance to fatigue. The yield strength of ASTM A992 is approximately 345 megapascals, which allows it to withstand large amount of stress, helical loading without failure, dynamic loading conditions bridges face, such as traffic loads and environmental forces, require material that exhibit both high tensile strength and fatigue resistance. Steel ASTM A992 satisfies these requirements, ensuring that components like beams, girders, and columns remain stable under various load conditions. Next, heavy hex bolts 0325. Additionally, heavy hex bolts such as the 0325 bolt type are critical components that help bind bridge structures together. According to Zaruba 2020, the large diameter and tensile strength of these bolts allow them to resist shear forces, making them essential in maintaining the stability of the connection points, particularly between beams, decks, and columns. Proper bolting ensures that forces like wind and seismic activity do not lead to failure at the joints. The interactions between steel ASTM A92 and heavy hex bolt provide reliable system capable of withstanding both static and dynamic loads in harsh environment conditions.
Assalamualaikum warahmatullahi wabarakatuh. Saya Muhammad Nurdin Ibrahim. Hari ini saya akan terangkan tentang factor of safety untuk saya punya group projek. Pertama sekali, saya ingin menjelaskan dalam mana-mana reka bentuk, kita memerlu struktur reka bentuk, kita perlu memahami ciri-ciri bahan. Ini kerana dapat membantu kita menentukan sama ada bahan yang digunakan dapat menampung beban pada jangka masa yang lama ataupun sekejap. Yang pertama adalah heat strength. Heat strength ini adalah kekuatan kehancuran, iaitu di mana tahap tekanan bahan mula tahap tekanan di mana bahan mula bengkok ataupun berubah bentuk secara kekalnya. Sebagai contoh, kita dapat menggunakan getah sebagai contoh. Apabila getah itu terlalu kuat, ditarik terlalu kuat, ia tidak akan kembali ke bentuk asalnya. Kemudian tentang ultimate strength. Ultimate strength ini adalah tahap tekanan maksimum yang boleh ditahan oleh bahan sebelum ia menjadi berubah bentuk ataupun rosak. Untuk kita orang punya reka bentuk, jika kekuatan kita orang punya group projek, bahan yang digunakan adalah steel dengan aluminium. Ini dapat menunjukkan material tersebut dapat menampung bebanan yang tinggi untuk bertahan dengan lama. Dua adalah tentang design specification. Specification ini kita kena mengetahui tentang dimension dengan loop condition. Pertama, dimension. Seperti yang kita dapat lihat, reka bentuk yang kita orang ambil ini dia mempunyai ukuran ataupun saiz bentuk dan ketebalan komponen struktur itu yang tinggi untuk menampung bebanan tersebut. Loop condition. Loop condition ni kita dapat melihat dengan berat struktur itu sendiri dengan bebanan yang akan dikenakan nanti. Apabila kita telah mengetahui tentang dimension dengan load condition, kita boleh memastikan struktur yang kita ingin membina itu mempunyai untuk keselamatan yang tinggi ataupun rendah. Yang ketiga adalah load data. Load data ini adalah daya yang tetap dan tidak berubah-ubah. Contohnya berat tangki air, berat roda itu dan berat struktur itu sendiri. Yang terakhir adalah struktur analisis calculation. Untuk sebelum kita membuat struktur tersebut, kita hendaklah mengira applier stress. Ini adalah daya atau tekanan sebenar yang dialami oleh struktur apabila beban dikenakan. Ada satu formula yang untuk mengira tekanan, untuk mengirakan beban tersebut ialah tekanan sama dengan daya perluas. Selain itu, kapasiti. Apabila struktur itu dapat menampung beban yang kecil, tetapi kapasiti yang dikenakan. Itulah daripada saya. Terima kasih.
So, comes to our free body diagram. A free body diagram is a graphic dematerialized symbolic representation of the structure in which all connecting pieces have been removed. Next, free body diagram are tools that are used to visualize the forces and movement applied to a body and to calculate the resulting reaction in many types of mechanics problems. Hence, this is our free body diagram of structure of bridge. The free body diagram consists of several components, which is simplified version of the bridge. A coordinate system and forces are represented as arrows pointing in the direction that act on the bridge. Next, continue to our methodology. Firstly, we had used the formula F equals to area under consideration to determine the concentration load of the whole structure. Hence, we can obtain the value of concentration load is 50 kN by assuming the distributed load is 3 kN per meter square and the total length of the maintenance bridge is 5 meter. Next, this formula is also used to determine the concentration load of the half structure, which is 3 kN by using the assumption length of 1 meter. To calculate the centroid of the whole structure and half structure, the formula, which is 1/2 multiply length, is used to get the value of centroid, which is 2.5 meter for whole structure and 0.5 meter for the centroid of half structure. In addition, by using this formula, the internal force can be determined. Method of joint based on the equilibrium of forces is used, which ensuring that the sum of forces and movement at each joint or section is 0. By using equilibrium of forces and method of joint, the calculate value of Qy, Fab, Fbc, Fde, Fcf, Fcd, Feh, Fef, FHF, and FRH is negative value. This is due to the reason that these forces are known as compression. However, the calculated value for FBF, FDF, FGF, FGH, and FGQ is positive value, which is known as tension.
Next is our analysis part. The structure is subjected to the axial loading. The internal forces and corresponding stress are normal to the plane of the section, which is the normal stress. To analyze the normal stress act on each member truss, we have used a formula, which is the normal stress is equal to the internal resultant force distributed divided by the cross-sectional area of the structure. For the truss member in compression, the normal stress or tension will be negative, and for the truss member in tension, the normal stress or tension will be positive. Based on our observation, the structure is made up with I-beams instead of solid rectangular beams. We could observe that a large joint is fastened together using 4 bolts to connect the I-beams to one another. When bolts are subjected to loops, the bolt stretch which creates a state of stress on bolts. To calculate this shear stress occur on the bolts, we have used the formula which is the average shear stress is equal to V/A. V is equal to the internal resultant force act on the bolt, and A is equal to the cross-sectional area of the bolts. Next is our discussion. We have discussed about the factor of safety of the structure. Factor of safety is an essential major part when designing and engineering structure. We have used a formula which is F of S equals to failure stress divided by allowable stress. Then we have obtained the F of S is equal to 1.3, which is greater than 1. For F of S less than 1 is not stable, since the structure will not be capable of supporting any extra loads. The factor of safety have represent how much the stress is within the allowable limit. The higher the number of FOS, then the safer the structure is. We have also obtained the maximum allowable stress of the structure is equal to 344.74 megapascal.
My name is Vasika Alaki Murali and metric number is B0922200036. So today I'm going to present about the conclusion for the solid mechanics assignment. As a conclusion, force and factor of safety analysis is critical in structural engineering to assure the safety, durability, and long-term viability of critical infrastructure like bridges. Engineers can design structures that can handle both predicted and unexpected pressures by taking into account a variety of forces such as dead loads, lift loads, dynamic forces, and environmental conditions. The factor of safety adds a margin to account for uncertainties in material qualities, construction processes, and environmental variables, guaranteeing that structures can withstand loads above their projected limits without failure. Still, ASTM A992 and X-Ports provide the essential strength and stability, while regular maintenance and cutting-edge technology like structural health monitoring, sensor networks, drones, and AI-based monitoring provide real-time data for proactive maintenance and repairs. Engineers ensure that structures like bridges stay safe, reliable, and useful for combining careful design, material selection, ongoing monitoring for analysis, thereby safeguarding public safety and supporting infrastructure need for decades.